Our seventh rule is called addition. Addition is also a very simple rule. It's so simple that it can actually throw people. It can actually be confusing. What addition says is that if P is true, then P or Q is true, right? What does that mean? Well, if we know P is true, we're entitled to say that P, or actually anything we want, is going to be true. Why is that? What does P or Q mean? It means that one of these two things is true. But if we have a premise that tells us P is true, we know we're entitled to say P or Q is true. So my father's name is Joseph. And if you know that, you're entitled to say Professor V's father's name is Joseph or Mike. Professor V's father's name is Joseph or Frank. Professor V's father's name is Joseph or Dennis. You could go on and on. As long as you know that P is true, you're entitled to say P or whatever you want. So, this would be an example of addition. If we know that E and F is the case, we're entitled to say E and F or T. Why is that? Well, this has to be true since we know that E and F is already the case. If you know that Sacred Heart is in Fairfield, you are entitled to say Sacred Heart is in Fairfield or Sacred Heart is in New Haven. Right? As long as you know that Sacred Heart is in Fairfield, you can add whatever you want into an or statement. So let's use this in a proof. You're trying to establish Z, right? So here Z sits at the end of an if-then statement. So we know what we really need to establish is not C or T. That's what's going to get us to Z. Okay, now, how are we going to get not C or T? Well, I could probably get not C using these two lines. Notice line 1 tells me if C is true, E is true. Line 2 tells me not E is true and F is true. Well, if both of these things are true, I know I can say not E is true. I'll use simplification for that. That's going to get me to not C, and then I'm going to use addition. Now, if that confused you going backwards, let's just go forwards, right? We're still at the stage where we can kind of go forwards, and we'll do okay, right? What can we do looking at a couple of these lines here to add to our body of information? Well, you look at lines 1 and 2. Line 1 says, if C is true, E must be true. Line 2 includes the idea that E is not true. But we need to grab that so we can use it, right? If it's true that not E is the case and F is the case, well, then not E is the case by itself. We're just simplifying line 2. Now we can use not E to get not C. That's modus tollens on lines 1 and 4. Now notice, we want Z. In order to be able to get Z, though, we need not C or T. But we've already got not C. That's where we use addition. We need to add T to not C. Right? Feels a little bit like cheating, right? We can add whatever we want. Well, you can add whatever you want into an or statement if you've got that first thing, right? If we know not C is the case, I'm entitled to say not C or T. Now, as an aside, I would not be entitled to say not C and T, right? Because that would be saying both things are true. There's no justification for that. But if I know not C is true, I can say not C or T. I am justified in saying that. Now that I have not C or T, I can conclude Z using modus ponens on lines 3 and 6. So we use addition when we need to create a disjunction and we only have the first half of that disjunction.